Camps on everyone. Let's start off. Yeah, great. So hope everyone is able to hear me right clearly. Great. If there is any lag or something, do let me know. Great. The last thing that we did was spherical cells. Hope everyone has gone through this stuff, right? But anyone has seen the recent advanced paper? They slotted them. नहीं but paper में फिर भी there were questions like थोड़ा manageable. If you guys remember, this question came. Which one? There were a few questions like, remember efficiency of a cycle in thermodynamics? That thing was asked. Like, yeah, the process was different. Then they asked question on, that one. The particle has force F is equal to minus K by R power N. It is oscillating. Find the time period kind of thing. ये question याद है वो कौन था? There is a particle, there is a block attached, angular momentum is conserved. Remember that? In SHM we did that. So there were a few models and there was one question on modern physics that you won't know. So yeah, but the paper was kind of like, when you see the questions, right, first thing you will panic. If you can keep yourself calm and if you have done all an easy moderate questions, I think there is at least 50-60% of the paper was doable. Matlab, if you don't panic. Paper one was still fine. Paper two was a little left. People got exhausted. So the problem क्या होता है ना actually? People look at mains का physics paper and they think physics मुझे आता है. Once they come for advanced and they get slaughtered. मेंस में वो प्रॉब्लम नहीं है, मैथ्स में वो प्रॉब्लम नहीं है, बिकॉज मेंस ऑल्सो स्लॉटर्स यू, एडवांस ऑल्सो स्लॉटर्स यू, सो यू फील लाइक ये तो नॉर्मल है. So I think that's why people are finding it more difficult. But yeah, if you see with respect to maths, I think it was proper. But anyway, you should solve that paper later on once you get time. Once the portion gets over, that will be a good time to write. But yeah, let's go ahead. Let's do one more question before going ahead with parallel plates. Let's see how much you remember this. Let's say we have three shells. Mm, mm, Maybe I'll put two shells only. I'll just ground this. This is R, and this is 2R. This thing is minus Q, and this thing is plus Q. Find the charges when the switch is closed. Just a problem, just to see how much you remember. Let's get this thing. Let's get this. Okay, we have got an answer. Anyone else? Straightforward, right? Whenever you ground something, you know what will happen. Samya, yeah, right, Sabek. Right, Param. Yeah, most of you are getting it. So let's see. So the moment you ground something, first thing, charge is not conserved. Second thing, the potential becomes zero. So let the charge be small q. This will be minus q, and this will be q plus q. Why? The charge has to be conserved on the outer shell. Now the potential at this point, VA, must be equal to zero, which will be k small q by r plus k q plus q minus q by 2r is equal to 0. This would give you q is equal to minus q by 2. And that's your answer. So you get the charges. So this is q by 2, this is q by 2, and this is minus q by 2. Easy? Like I said, it's a standard mains level question. You should be very comfortable with this. Right? Later on in capacitors, we will see this thing. There I'll ask you find the heat produced. You can do it here also. But yeah, it will become a little complex if you try to do it here. But think about it, how to find heat produced here. You want to try? I'll give you a minute. Think how to do heat produced. So when I close the switch, you'll get a heat produced. Find the heat produced. Let's try that. Now, if I ask you heat produced, the question actually goes a little beyond. It's You can do it here in Gauss law, but in capacitors it is much easier to do. But फिर भी try करते हैं एक minute. Give it a try. Think about it. How will you find heat produced when the switch is closed? So I'll add that also. Charge distribution and heat produced. Now you need to understand, heat will be, whenever there's a charge flow, heat will always produce. A simple logic. Every system will try to attain a state of least energy. Yeah, the statement. So the reason why the charges are flowing is because the, the charges will flow in such a way to reach a state of lower energy. That means the energy level has decreased. So all that energy went where? It must have gone somewhere. So that becomes heat. So you can remember that whenever charge flows, see, if a system does something, वो charge का बात ही नहीं है, anything. Water flows. Why does the water flow? It goes from higher height to lower height. Why? Because it wants to decrease the potential energy. Right? Anything, if you see in a nature, anything it moves or something it tries to change, it is always to achieve a state of lower energy. And whenever it does that, you have to lose that energy somehow. In these kind of systems, it is heat. So let me show you how the system looks initially and finally, and let's see if we'll get some ideas. So this is before the switch was closed. And then what were the charge distributions? Minus Q, plus Q, and 0. This was the initial charge, isn't it? This is before the switch was closed. How do you find energy for this system? Huh? See, I'll tell you. We can treat this as two different shells. Think of like this. This is one shell of minus Q and radius R. So this is how you construct this system. We'll just show it here. Wait. First, construct a shell of minus Q and radius R. So this will have self-energy. How much is the self-energy? K minus Q whole square by 2R. Great. Then you constructed another shell of plus Q. This will also have a self-energy K Q square by 2 times 2R. So this is the energy required to construct the shells. Make sense? Now you want to combine both the shells. How are you combining this? You are planning to bring the shell. So think of like this. So this guy is at infinity. So you're planning to bring the shell from infinity and put it on top of this, isn't it? So this thing comes from infinity right? And becomes concentric. Perfect. What is the potential at infinity? Zero. You're getting it? What is the potential on the surface here? Minus kq by 2r. Understand one thing. To create each shell, it requires self-energy. Now, if you bring both the shells, do you think they'll keep quiet? There will be also some interaction between them, right? It's like this. We got a shell of minus q, we got a shell of plus q, and you're trying to bring it closer. Won't it attract? So won't you have to provide energy for that or take energy from that? So there is also an interactional energy. So this gives you something called U interaction energy. So this is the energy required to combine them. So that will be charge Q, that's what you're bringing, into V surface minus V infinity, final minus V initial. That would be Q into minus KQ by 2R. Perfect. So therefore, the initial energy of the system will be KQ square by 2R, the self energy, KQ square by 4R, the self energy, plus minus KQ square by 2R. These two are self energy terms. This is the energy required to construct the shells. This guy is the interaction energy term. This is the energy required to bring them together. If you add all this, you will get the combined energy. 2 square will cancel. This is KQ square by 4R. Are you sure how we did this? So initially the system has this much energy, KQ square by 4R. Any doubts on this? They can simply ask you this question: what is the energy of this system? All clear with this? So we have two self energies and one interaction energy. Now, question still not over. Now, can you do the same thing for this guy? If you can find this energy, and if you subtract initial minus final, the difference must be heat, isn't it? Are you getting the logic there? Like I said, there is a much easier and faster way to do, which we'll see in the next class, maybe our next class. But let's see how we'll handle this using self energies interaction. Can you find the energy for this system? No, before starting, let me ask you, how many self energies are there? How many self energies are there? 1, 2, 3. There are 3 shells. There are 3 self energies. Be careful. And then how many interaction energies are there? Listen. First, you will put minus q by 2 to bring it here. Do we need to give an energy to bring it here? No. Then we'll bring the next q by 2. There will be interaction between them. Then we'll bring one more q by 2. These two will interact with q by 2. You're getting it? So there are 2 interactions and 3 self energies. Give it a try. Then I'll show you.
So there should be three interactions, right?
It depends on how you want to call it. So I was calling this is 1, and I'm calling these 2, and this is 1. So
Okay.
yeah, but if you actually say that way, right, it'll be like 1, 2, and 3. Yeah, you can say that also. But remember how we are calculating. We are bringing one at a time, and we are seeing how much energy requires to bring one at a time. So first I'll bring the inner shell. There is no one, so there is no problem. When I bring the second guy, 1 and 2 will fight. When I bring the third guy, 1 and 2 will fight with the third guy. You're getting? So that is how I do normally, but yeah, see how it works for you. Find the energy of this system. This itself is a question, finding energy of the system. And do remember this, huh? Same question I'll ask you in capacitors, and then you will see why it's more easy there. But for now, let's do it. It's good. Like it will help you to understand how to take the self energies and stuff. I'll give you a minute more, then I'll show you. You can verify your answers. Okay, let's see. You keep trying. By the time I start and all, you'll get another minute or two. So you wanted to construct three things, right? So I'll just put three shells. So this guy, and this guy. So this was minus q by 2. Yeah, numbers are little bad at a distance r. This is q by 2. And now be careful. Huh? One of the mistake people do. They say, sir, since both are on the same thing, why can't I just take total charge as q? Don't do that. These are two different hollow shells because look at the formula. The formula is kq square, isn't it? It's not a linear function. You can't add them directly. You have to treat them as two different hollow shells. So what is the self energy? K q square by 2r. K q square by 4 2r. K q square by 4 2 times 2r. K q square by 4 2 times 2r. These are self energies. To construct each shell, you require this much energy. Now let's construct them. So I'll bring the shell here, minus q by 2. And you're trying to bring the first shell here. So all these are at infinity. They're very far. So potential at infinity was 0. When you bring it to this surface, the potential here on the green one is only due to the minus q by 2, which is minus k q by 2 by 2r. So to bring the first shell, you require an energy of charge. How much is that? You bring in q by 2? V surface minus V infinity. That would be minus kq square by 8r. Perfect. So what did you create? You created this and this. So you created minus q by 2 and you created q by 2. And now you're planning to bring the third shell here. So you're trying to bring this here. Luckily here, V infinity is 0. V surface is also 0, isn't it? Because see, minus kq2 by 2r plus kq2 by 2r, the potential on the surface becomes 0. I'll calculate it for you if you want. V surface will be minus kq2 by 2r plus kq by 2r because the charges are equal. This is 0. That means this interaction is 0. So when you want to bring the third one, you don't require any energy. Yeah, it's a little big, so perfect. So what's the total energy of the system? Add up everything. So U final will be kq square by 8r plus that is kq square by 16r plus kq square by 16r. These are three self energies minus kq square by 8r. That's your one self energy. And then when you add it up, 8 and 8 will cancel. You end up with kq square by 8r. Perfect. So this is final. And this is the initial kq square by 4r. So what happened to the heat? The difference, isn't it? The heat produced is U initial minus U final, which is kq square by 4r minus kq square by 8r. So basically half of the energy becomes heat. Is this clear, everyone? So self energies and interactional energies. So this is U self. Clear with this? Lengthy, but yeah, it gives you a good idea, like, how to construct the system and everything. Any doubts on this? You should definitely do this on your own once more, just to get that self energies and the interaction energies. Great. Next thing. So there, if you got this, I think you understood how to handle shells. Oh, now the second thing, what happens if it's parallel plates? Now then, slowly we have actually entered into capacitors. So like I said, the ending of Gauss law is the beginning of the capacitors. So let's see. So how do you take charge distribution on parallel plates? So consider two large parallel plates with a small distance between them. Right. So why large plates and why small distance between them? So there is a reason. So when you take this large parallel plates, and if the distance is very small, we can treat them as infinite sheets. So let's say if this was plus, and if this was minus, right? So we can treat them like infinite sheets, and we can assume the field is uniform. That's one big assumption we need. What happens if the plates are large? If the distance is large, let's say you're taking them really large, and then now what happens? Lines will still be parallel here, but as you start going to the edges, right, the field lines will start actually bending. You will start seeing lines are curving and bending and doing all these kind of things. We don't want to deal with this stuff. This thing, right, on the edges, this is called a fringe effect. Fringes are basically edge. So we cannot assume the field is parallel anymore. And if it is not parallel, things will get messed up. We don't want to deal with this. So that is one big assumption we do. Clear with this? So that is the first thing, why the plate should be large and the distance should be small. This keeps our life little easy. Clear. And when we say D here, exactly what is this D? D is very small compared to the dimensions of the plate. For example, if side of the plate is 1 meter, maybe D is 1 millimeter, 1,000 times smaller. That is the meaning of small. Any doubt so far on this? All clear? Great. Next thing. So I gave you two plates. Distance is small. I gave charge here plus Q1. I gave charge here plus Q2. Straightforward. That's it. And the question, how will this charge distribute? Can we just see and tell the answer? We don't know, right? So let's start like this. We want to find the charge distribution. So let the charges be Q1. Then this must be Q1 minus Q1. Why? Because charge is conserved. This will be Q2. Now be careful. Don't say this is Q1, this is minus Q1. We have proved for a hollow shell, it is equal and opposite, isn't it? We never proved for parallel plates, which is true though, but we have to prove it. This would be Q2 minus Q2. So there are two variables. Now what we do, consider a Gaussian surface. We still play the same game. So this green box which I'm taking, remember this will be actually a 3D. Now if you observe the Gaussian surface, the two left edges are inside the metal, right? And the outside things are, if you see, the field is this way here and the area vector is this way. The field is this way here, area vector is here. So wherever there is field, the area vector is perpendicular. Inside the metal, the field is zero. Therefore, the flux is zero. So therefore, the charge Q1 plus Q2 must be zero. There we proved it. So not only for shells, even for parallel plates. If you keep two parallel plates, they will always have equal and opposite charge. That's it. There's no discussion. This is the first thing you need to remember. In case you're still wondering how will this surface look like, let me just draw one more picture for you. So these are the parallel plates. So your Gaussian surface is looking something like this. Able to visualize? That is how your Gaussian surface is looking in 3D. Right? So the two left-hand sides, the field is zero because they're inside a conductor. The remaining four faces, E is perpendicular to A. The total flux is zero. Great. So that means, so when now I can simplify this diagram into like this. So whenever you keep two parallel plates, this is how the charge distribution will look like. If this is Q, this has to be minus Q. Then this will be Q1 minus Q, and this will be Q2 plus Q. We eliminated one variable. So if I can find small q, my job is done. So this is the first thing you need to remember. In parallel plates, whenever you keep them facing each other, they'll always have equal and opposite charge. Sudiksha, Shreyansh, Pratyasha, Advait, I can't see you guys. So please adjust your cams a bit. Ashwi, adjust your camera a bit. Make sure your faces are visible on the screen. So this is our first statement. Like I said, right, there are four things to remember. This is the first thing. So the faces of a conducting plates facing each other have equal and opposite charge. That's your first thing. Next thing. Great. So now you got that distribution here. So you're saying this is Q, this is Q1 minus Q, this is minus Q, and this is Q2 plus Q. Perfect. Now, how do you find small q? Consider a point inside the this thing Gaussian surface. So let's consider a point A. Now, A is inside the conductor. So you have chosen a point inside the plate. Therefore, the field must be zero. Why? Because it's a conductor. Now, if you see that statement, right, field inside a conductor, we are just using it like anything. So EA is zero. Due to what? Due to all charges. That's the thing. Due to all charges, it is zero. Now, for our convenience, let me just draw this picture again. So this charge is Q1 minus Q. I'm separating the sheets. So this is plus Q. This is your minus Q. And this is Q2 plus Q. Can I write this thing as four sheets? Right? So there are four sheets. So what I'll do, I'll color them for you. So let's call it this thing green. So this guy will give a field how much? In case you remember, if the plate has sigma, the field is given by sigma by 2 epsilon and sigma by 2 epsilon. Sigma is nothing but charge by area. So I will change the colors accordingly. So the green one will give a field. I'll assume everything is positive. The signs will take care of them. So Q1 minus Q by area. Q1 minus Q by area by 2 epsilon. So that is the field at point A. I'll color this with red. This is also positive. So this also will give field in this direction, which is small q by area by 2 epsilon. I'll color this in black. Since this is a negative charge, it will attract this way. The field will be q by area by 2 epsilon. The minus sign indicates direction. So I have taken the direction. Let's color this also with some other color. So I'm just finding the field due to the 4 plates. So I'll assume this is also positive. The field will be this way, which is q2 plus q by area by 2 epsilon. Are you getting what I did? I found the field due to the 4 plates at point A. And I'm going to say all these 4 should cancel out to give you a 0 field, isn't it? Isn't that the meaning of the field at a point A? So that's field due to everyone there. Now, if you can clearly observe here, you will notice this red and the black one get cancelled out. This guy and this guy do cancel out. This and this cancel out. So this green one and the yellow one will be left out. I'll just write in that same color. So you will be looking at Q1 minus Q by 2A epsilon must be equal to this yellow guy, which is Q2 plus Q by 2A epsilon. And when you solve this, you will clearly see Q1 minus Q is equal to Q2 plus Q. We get Q is equal to Q1 minus Q2 by 2. There, we got the result there. Is that clear, everyone? That derivation is fine. It is decent one. So what we did was simply, I said, I don't know the charges. I said, let it be small q. Then I got 4 distributions. Then the argument was due to these 4 of them at point A, the field should cancel out. These 4 can be treated as 4 infinite sheets. So these can be treated as 4 sheets. I found the field due to each of them, which is sigma by 2 epsilon, and I just cancel them. All clear with this? So what is the final result? So if you take 2 parallel plates, and if you give Q1 and Q2, the final charges are outside, you'll get Q1 plus Q2 by 2, Q1 plus Q2 by 2. Inside will be Q1 minus Q2 by 2. And this will be minus of Q1 minus Q2 by 2. That's your charge distribution. Clear with this? Now, you can do even better. Now listen, this is not that important. The next one is more important. What if I have n plates? This, if you remember, the 2 plates will anyway get covered. So listen carefully. We will not do the whole story again, but you'll get the hang of it. When I take n plates, and let's say they have charges Q1, Q2. Now, these charges can be positive or negative, doesn't matter in Q1. Listen to my argument. We proved the charges inside are always equal and opposite. So one thing I'm sure, if this is Q1, this is minus Q1. If this is Q2, this is minus Q2, and so on. Agreed? Now, if I consider any point here A, the same story, look at this carefully. This Q1 will repel, this minus Q1 will attract. Agreed? They both will cancel. Similarly, Q2 will repel, minus Q2 will attract. They will cancel. That means all the charges in the middle will cancel out. And the only thing that is left is this outmost charge, let's call it Q dash, and this charge, let's call it Q double dash. Only these two are left. Again, because the field has to cancel, the Q dash ka field and Q double dash ka field also should cancel. Therefore, we can say the outside charges must be equal. Is that making sense? It doesn't matter how many plates you take, the charges on the outermost surfaces must be equal. So far clear? And the second part, now see, since the total charge is conserved, Q1 minus Q1, 0, Q2 minus Q2, 0, Q dash plus Q dash must be total charge, which is Q1 plus Q2 plus 1 Qn. Therefore, Q dash will be sum of all charges by 2. You're getting this? So you can just prove it like that. So I'll just write on the final result. You can remember that result. It helps a lot, saves you a lot of time. That's how you can just prove it. So if you have two charges here, this charges will be, I'll just call it X, or I'll just write it on here. This is Q1 plus Q2 plus so on by Qn by 2. It's not by N, it's total charge by 2. This is again Q1 plus Q2 plus so on till Qn by 2. Then what is the charge here? This will be Q1. Maybe let's call this thing as some X or something. Then this will be Q1 minus X. And then this will be Q1 minus X and so on. You can just charge conserve and solve it. Are you clear with this? So the charges on the outermost surfaces will be total by 2. Let me show you an example. Yeah, the questions are really not that hard. Once you got the results, right? Remember, I taught you two results till now. What are the results? The facing plates will have equal and opposite. What is the second result? The outside charges will be total by 2. So let's say I give you 3 plates. And let the charges be plus Q, minus 2Q, and 3Q. And I ask you what is the charge distribution. So what is the charge outside? Q total by 2. How much is Q total? 4Q, that is Q. Agreed? If that is Q, this is also Q. Now, if this is Q, because the charge has to be conserved, this should be 0. If this is 0, the facing plate should have equal and opposite charge. So this is also 0. If this is 0 and this is minus 2Q, then this charge has to be minus 2Q because total is conserved. And this has to be plus 2Q. Do you guys get this? I'll give you one. Now you guys tell me what is the answer for this. That's it. So once you know this thing, right, questions are like straightforward. Like there's really not too much to think. And second thing, if you notice, right, it doesn't matter what is the distance between the plates. Let's say there are 4 plates. So let's say this is plus Q, minus 2Q, this is 3Q, and 4Q. Can you tell me the charges? Fine, I'll give 30, 40 seconds. Remember, there's only two things. One, that outside charges is total by 2. And then once you got that, then you can say by charge conservation, you can find the charge on each plate. Try, give it a minute, and I'll show you this thing anyways, but yeah, right, Samyak. Right, Param. Did everyone get it? Should I show you? See, find Q total. The outside charges Q total by 2. How much is that? 4Q, Q, 8Q, 6Q. That is 3Q. This is also 3Q. Start from anywhere. If this is 3Q, this has to be minus 2Q. Why? Because total has to be plus Q. Clear? That's the argument there. If this is minus 2Q, the facing plate should have plus 2Q. If this is plus 2Q and this is minus 2Q, the total charge, this has to be minus 4Q. Then this has to be 4Q. Then this has to be minus Q. And this has to be plus Q. Please check your answers. Easy? So once you know the charge on the outer surface, right, by charge conservation, you can find the other side ka charge. And once you know that, you will say the other side has opposite charge and you'll just keep going ahead. Any doubts on this? There. So you have learned 2 points. What is the point one? Facing plates will have equal and opposite. What is point two? The outermost charges, outermost surface will have total by two. Great. So yeah, let's go ahead. Let's say we have three plates. There is a switch. This distance is d and this distance is 2d. Now I'm giving the distance between the plates. Let's say this is plus q, this is minus 2q, and this is 3q. Find the charge distribution when the switch is closed. Now, this is different. You know the charge distribution when the switch is open. That does not depend on the distance between the plates. But if you keep a switch like this, it depends on the distance. Find charge distribution when switch is closed. Give it a try. Give it a minute or two. It's a good one. Let's see how will you think about it. You know, right? What happens if you connect two things with a wire? The potential becomes same. This will be the third point. Give it a try for 1 or 2 minutes, then I'll show you one. Okay, let me help you out here. Listen. So I'll teach you a more general situation, then we will see this thing. So let's say we have three parallel plates. Let the distance be d1. Let the distance. I'll take a middle plate here, right? And they'll take two charges q1, q2. If this is q1, the left will be minus q1. The right will be minus q2. Everyone agrees with this charge distribution? I don't know what is q1, q2. I took a random thing. Now here the field will be E1. Here the field will be E2, positive to negative. What is E1? Charge by epsilon, sigma by 2 epsilon into 2 times because there are two of them. And what is sigma 1? Q1 by A, 2 will cancel epsilon. Similarly, what is E2? Sigma 2 by 2 epsilon into 2 times because there's a positive and negative. This is Q2 by A epsilon. Any doubt still here? Each sheet will create a field of sigma by 2 epsilon into 2 because the negative will attract and positive will push, so they'll add up. If you want, I'll show that also. So this guy will generate a field of Q1 by A, that is your sigma by 2 epsilon. This guy will also generate a field of Q1 by A, that is sigma by 2 epsilon. That will give a field of E1. Makes sense? Now, tell me one thing. If I number these plates as plate 1, plate 2, and plate 3, the potential difference between plate 2 minus plate 1 is simply the field E1 into D1. Do you agree? Integral E dot dr. Yes. Potential difference is field into distance, right? Or integral E dot dr, which comes out to be E1 D1. Similarly, the potential difference between plate 2 minus plate 3 is again minus integral E dot dr. That is again E2 D2. But we know V1 is equal to V3 because both are connected by a wire. Therefore, we get E1 like this. Then these charges will be in the ratio of Q1 D1 and Q2 D2. So let me just put that down again. So that's your final result. So if this was T1, this was T2, and if this charge was Q1 and this charge was Q2, then we can say Q1 D1. So this Q1 into this D1 is equal to Q2 and D2. That ratio they will always maintain. Example, yeah, let's say this was D and this was 3D, right? And let the charges on the plate be plus Q, minus Q, and let's say this is some 3Q. They give something like this. Then we will say like this, let this charge be Q1, let this charge be Q2. Then we know Q1 into D is equal to Q2 into 3D. That is Q1 is equal to 3Q2. That is equation 1. But we also know Q1 plus Q2 must be minus Q. The total charge is conserved. That is your equation 2. You can solve these two and you can get Q1 and Q2, isn't it? Understood how we did this? This is your third result. If you have a wire across them, then Q1 into D1 becomes equal to Q2 into D2. Now can you guys do this? Right, now I'll give you a minute. Now this you should know. This is the third point. This is what I was saying. There are 4 points. This is the third one. So you know all 4, then parallel plates, you can handle everything. Any doubts on this? Anyone not clear with anything, please ask. All got this? So you're closing the switch. Remember, the second thing is still valid. Huh? What is the charge outside? Total by 2. That story is still true. This is Q total by 2. That will not change. How much is this guy? 3Q plus Q minus 2Q. This is Q and this is Q. This much you can be sure. Now, do I know how much is here? That I don't know. Why? Because maybe some charge has gone from here to here or charges come from here. I don't know that. But then, yeah, I will assume this is Q1, this is Q2, then this will be minus Q1, this will be minus Q2. The signs will take care of themselves. And then you will say Q1 into D is equal to Q2 into 2D. We get Q1 is equal to 2Q2. And the charge on the middle plate is conserved. is minus 2q, which is q1 plus q2 is minus 2q. Take q1 here, substitute here, you end up with q2 is equal to minus 2q by 3. q1 is equal to minus 4q by 3. Those are your final charges, everyone. Easy? Any doubts on this? Tanishka? Utsa? Clear with this? Vanshika? Sudiksha? Priyansh? Shreyan? Param? Advai? Samyak? No. Do this thing. This is the actual question. Let's say there are 4 plates. Plate 1 and 3 are connected. Plate 2 and 4 are connected. This distance is d. This distance is d. And this distance is 2d. Let this charge be plus q. This charge is minus 2q. This is 3q. And this is 4q. Find the charge distribution on the plates. This is a better variation, more than 3 plates. So, yeah. Think. Take a minute or two. It's a worthy question. You know everything you need to solve. Remember the 3 tricks, huh? First thing, opposite faces will have equivalent opposite. Second thing, outside is total by 2. Third thing, q1 d1 is equal to q2 d2. But remember, that is for 3 plates. You can write that formula for these 3 plates. You can write that formula for these 3 plates. So that is how you do. You can take 3 plates at a time. And instead of remembering, understand the context of why are you doing this. You are doing this field into this distance, this field into this distance. So this potential difference is same. That's how you're getting that formula. So instead of blindly remembering, if you understand the context, yeah, you will actually remember the formula. So try. Get something wrong, that's also fine, but give it a try. I'll give you a minute. Okay, let's see. Step 1, find the total charge. How much is the total charge? Total by 2. What is total? This is q total by 2. Listen carefully. It's not difficult. Like once I show you, you will feel like, oh, I got it. I'll ask you one more like this. What is the q total? 4q, 8q, 6q, and that is 3q. If that is 3q, this is 3q. That's it. There is no doubt about it. It works. Great. Next thing, I don't know the charges. So listen carefully what we do. Let this be x. If this is x, this is also x. Do you agree? Why? Because see, x into d, x into d. So Because both are D and D, that should be X and X. Any doubts on that part? If this is X, this is minus X. This is also minus X. If this is minus X, this has to be minus X by 2. Why? Minus X into D, and this thing, the product must be same. So minus X into D must be equal to minus X by 2 into 2D. Are you sure with that? Now, if you are really not happy with that, I'll just call it Y, and I'll prove Y is minus X by 2. Great. If that is minus X by 2, this has to be plus X by 2. Okay? If you see, there's only one variable. Now, what is the charge on plate 1 plus 3? If you take the charge on plate 1 and 3, that has to be 4Q. But from here, what is the charge here? 3Q, minus X, and minus X by 2. These are all the charges that you have on 1 and 3. So this is 3Q minus X, minus X, minus X by 2 is equal to 4Q. That would give you X is equal to minus 2Q by 5. So once you got that, you got everything. Are you sure, everyone? Any notes on how we did this? Roughly got an idea? I'll give you one more. The best thing to do is that only. Like, you will, if you do one more, I think you will get the hang of it. Now you guys try this. This is D, this is 2D, this is D, this is plus 2Q, this is plus 3Q, this is minus Q, and this is 4Q. Find the charge distribution. I just change the numbers and the distances. Okay. Ram got something. Let's see. Anyone else? Okay. Let's see. So what is outside? Total by 2. That story will always remain same. How much is that? 43729 minus 1884Q. This is 4Q. This is 4Q. Great. Let this be X. This has to be minus X. If this is X, remember this is X into D. This has to be X by 2 because X by 2 into D by 2. That is X by 2. This is minus X by 2. This is minus X by 2. This has to be minus X. Again, why? Minus X into D is equal to minus X by 2 into 2D. If that is minus X, this is plus X. You can take even plate 3 and 4. So 2 and 4. Charge on plate 2 plus 4. You can take 1 and 3. Doesn't matter. Answer will come same. is 7q. That must be x by 2, x and 4q. This 4. That's x plus x by 2 plus x plus 4q is 7q. That is 5x by 2 is equal to 3q. X is equal to 6q by 5. Check your answers. Once you got x, you got everything. You could have taken 1 and 3, it would still work. Is this logic making sense, everyone? Now it looks doable, right? So when you see 3 plates and a wire and all, it looks really scary, like what the hell, but that's 3 things. Any doubts on this? All clear with this? Take a break. Come back when N40. We'll continue from here. Yeah, all cams on. Let's start off. I think I'm on mute. So the fourth thing was this earthing of parallel plates. So till now we have done three things, right? One, the outside is total charge by two. Second thing, opposite plates, facing plates have equal and opposite charge. Third thing, Q1 D1 is equal to Q2 D2. That is when you have a wire across it. The fourth thing is earthing of parallel plate. So what happens if you earth a parallel plate? Yeah, this is actually the easiest one, but let's see how we get this. Now, there is no direct way to prove this, but we go with an argument. So let's say we have n parallel plates. That we proved. And we also proved the charges inside will be Q1 minus Q1. This is Q2, this minus Q2, and so on. So the facing plates will have equal and opposite charges. Now, if you look at the system, the facing plates, facing surfaces have equal and opposite charge. Right? That is, therefore, if you look at these two things, the potential energy is negative. K Q1 Q2 by R. And whereas the charges on the outermost surface are like charges and they form a repulsive pair. Because they're always like charges, they will always create a positive charge, positive energy. Great. And now, when you're grounding the system, you know what you're telling? You're telling the system, boss, you can take any charge you want from the earth, right? Just make sure your system has the minimum energy. Isn't that what any system will try to do? If you give an opportunity, every system will try to achieve a state of minimum energy. It's like, imagine, right? See, you don't want to study, you don't want to do anything. What will you do? You'll sit in front of Netflix, watch a TV series, and take a bag of chips and start eating, isn't it? You will try to achieve a state of least energy. Like you don't want to do anything, you just want to sit there and do nothing. Yeah, it gets boring after some time, but then you'll just change the channel and watch a new series. So, you might change the chips to pizza or something. So the point is that. So when you're grounding the system, right, you're giving an opportunity to the system and saying, boss, you take whatever charge you want. Just make sure you have the minimum energy. That's the main idea there. So when any plate is grounded, the system achieves the minimum energy, right? Minimizes the energy by eliminating the outermost charges. Because think about this. The inner surfaces are positive and negative. They always form negative energy, and system is happy with this because negative energy systems are stable. The only problem are these two guys who are creating a positive energy, the two outermost surfaces, isn't it? What is their energy? K q square by whatever is the distance. What is the minimum value of a q square function? Zero, isn't it? You can't get a negative value by eliminating outermost charges. So that's it. So that's the whole idea there. So whenever you ground any plate, the charge on the outermost surface is zero. I'll show you some examples. So this is your fourth point. That's it. If you know these 4 points, you can handle everything. What about the first point, like total charge beta? That is still valid, but your total charge becomes zero. Let me show you an example. Listen to this example. If you got this, I think then you got it. Let's say we have 3 plates. Let the charges be plus Q, and this will be minus 2Q, and let it be 3Q. Okay? Now see. I will take different cases there. So the first case, I will ground the first plate. Now listen carefully here. What is the first step? If you ground any plate, what is the charge on the outermost surface? Zero. That's how you start. Why am I not writing total by 2? Now listen to the problem there. Is everyone listening? You need to focus on the class. Shreyan, others, Utsa, Arya, cams on. Yeah, you guys need to focus on the class. I'm not sure why you need to keep talking in the middle of a class, like, and that clearly tells you you're not really focusing. Like you, boss, this is not how you prepare for advanced or even means or bits. आपको पता नहीं सबको क्या लग रहा है, like वो advanced नहीं होगा तो bits कर लेंगे, bits नहीं होगा तो means कर लेंगे. This is not some, they're not just handing out chocolates or something like वो chocolate नहीं दे chocolate ले लेता हूँ. जाके देखो सब लोग, like people who study for advanced, these are the same people who actually crack mains and bits. Mains and bits is not a joke. So how do we start this thing? So the outermost surfaces will be zero. Now the question is, sir, why can't we use total by 2? Yeah, we can use it. So what is total by 2? 3Q minus 2Q. Can you say it is plus Q? No. Why? Because it is grounded. Charge is not conserved. Are you getting this? You cannot find the total charge because the charge is not conserved. So we start with zeros. Great. Can I find charge here? No. Why? Charge is not conserved. So start from the right hand side. So this is 3Q because total charge is constant. This is minus 3Q. This is plus Q and this is minus Q. That's how you start. You start from the other side, which is not grounded. And how much charge went into the earth? Initially, it was plus Q. Now it was minus Q. So total 2Q charge went into the earth. Let me take one more example. Let's say you're grounding the middle plate. Same story. What are the charge on the outermost surface? Zero. That's it. There is no doubt about it. You do anything. You ground any plate, outside becomes zero. If this is zero, this would be plus Q. This should be 3Q. Then this would be minus Q. And this would be minus 3Q. Initially, how much was there? Minus Q. How much now you have? Minus 4Q. So how much went into the earth? 2Q. So the total charge flows into the earth. Let's say I ground the third plate. Then I'm showing you all possibilities. So this is zero. This is zero. I'll start from left hand side because the right side is not conserved. This is minus Q. This is minus Q. This is plus Q. How much charge was there initially? 3Q. Now how much is there? Q. So how much flowed into the earth? 2Q. Please look at this example. So it doesn't matter which plate you ground, the total charge outside becomes zero, and everything else will be valid, whatever you learned. These are the 4 points. You know these 4 points, you can handle everything. All sure of this? I'll give you one more. You tell me what is the answer for this. Let's say you're grounding the second plate. Let the charge be plus q, minus 2q, plus 3q, plus 4q, and plus 5q. Find the charges on the surfaces. Okay, let's see. So what is the charge on the outermost surface? Zero. Zero. Then this has to be plus q because the total charge on this plate is conserved. If that is plus q, this is that is zero. This has to be 5q. This is minus 5q. And this guy is 9q. This is minus 9q. Wow, that's big numbers. And this guy is 12q. Interesting. This is minus 12q. Yeah, that's your charges. I will look at this. And what's the total charge? So 11q passes through this thing. That was the total charge. Since the total charge has become zero, the outer side will be total by 2. That thing is still valid. All clear with this? So you got all the 4 things you need for parallel plates. Outside is total by 2. Second, facing plates are equal and opposite. Third, Q1 D1 is Q2 D2. Fourth, if you ground any plate, outside will be 0. Now let's see the final form of this parallel plates. Grounding the third plate. I'm also connecting them with wires. This distance is D. This distance is 3D. This distance is 2D. Where I messed up the distances. This is plus Q. This is minus 2Q. This is 3Q. And this is 4Q. Find the charge distributions. There you got this. You know how to handle parallel plates. And numbers are bad. Maybe I'll make your life a little easier. Let's just call this also D. Now do it. I changed the numbers, huh? I changed it to D, 3D, and D. So it becomes a little easy. You got 2-3 minutes. Any answers? We have one. Try. I want everyone to try. I'll give a minute more. It's a good one. Hmm. Okay. Param and Arya got two different answers. Samyak got a different answer. We have three different answers. So I'm not sure. I was hoping some fractions though, but I'm not sure. Maybe there won't be any fractions. Param got in 3 by 2s. Arya got in 6 by 7s. Samyak got all integers. Interesting. Yeah. Solve. You got a minute more. Take your time. Get it. Remember everything that I taught you. Like all the four things are there in grounding, total by two, facing surfaces, Q1D1, Q2D2. Okay, let's see. Aditi is also saying 6 by 7 thing. So we have two people who got 6 by 7. 7, for some reason, I'm also feeling it might be right. I'm feeling, so I'm not sure. Feelings can be wrong. Anyone else? 6 by 7. If I get one more 7, then I think 30 seconds more, then I'll start showing it. So you guys should have solved it by now. Even if you got a wrong answer, that is okay. You shouldn't be that slow in solving. Okay, let's see. We'll start from outside. 0, 0. Great. Then I don't know. Like charge is not conserved. So we will start somewhere here. Let this be x. This has to be minus x. And remember, this is x into d. So this has to be x by 3 because x by 3 into 3d. So the sum must be there. If this is x by 3, this is minus x by 3. If this is minus x by 3, this would be minus x. Because again, x by 3 into 3d must be equal to x into d. I hope you have got these variables right. And this is plus x. Check. Now you have to be careful. I cannot conserve charge on 1 and 3 because it is grounded. You have to conserve charge on 2 and 4. I hope you didn't do that mistake. So that's the main thing there. Charge on plate 1 and 3 is not conserved. So I cannot say the total sum will be 4q. So you can't do that. If you have done that, that's a mistake. So be careful. So then we will say charge on plate 2 and 4 is conserved. Because that is not earth. If you earth something, you're gone. What is the charge there? We got x plus x by 3 plus x is equal to 2q. That would be 7x by 3 is equal to 2q. Yeah, x is equal to 6q by 7. So if you got 6 by 7, that's the right thing. Please check where you messed up. Maybe you conserved 1 and 3. That could have been a mistake. Or maybe you messed up the x by 3 or x or something. See where it went wrong. Clear? There. That's how you handle parallel plates. Last time we did shells and this is parallel plate. Technically, Gauss law here gets over. Getting it? But there is one more thing I want to teach you. This is a little out of the portion, but it could be an advanced, nice paragraph question. So let's see what is that. You got this? All got this? Next thing. So let's do this as a question and then I'll teach you something. Let's say we have a plus Q charge here and we have an infinite conducting plate. Which is grounded or earthed. So meaning the potential of the plate is zero. The perpendicular distance from here to the plate is d. Now we know if you put a charge in front of a conductor, what happens? If you see, if you put a charge in front of a plate, you are going to induce some negative charge. So minus q is induced. We don't know how much is minus q. So this plus q and this minus. Think for a minute. I'll teach you something, then I'll ask you something more. I can also ask the potential energy of the system. Okay, listen. Now, the concept here is called mirror image method. So technically speaking, right, they can't ask you this question directly. They have to tell you some story. They can explain you in a small paragraph. And then they can ask a lot of questions on this. So this is called a mirror image method. So what is the catch here? Listen. When you took a large plate and when you grounded this, the potential of the plate is zero. Basically, this is an equipotential surface. And when you kept a plus q charge here, and if you look at the field lines, we know the field lines will always enter the surface perpendicularly. Because if you remember equivalent surfaces, the field lines will always enter perpendicularly. And this is how the field lines will look like. Then he argues like this thing, right? What it says, if you take a plus q charge and if you take a minus q charge, right? And if you put a line exactly in the center, now think about this thing. And the distance between them is, let's say, 2D. If I ask you to draw the field lines, how will you draw the field lines? Think about this. Isn't this entire middle level, this entire dotted line, Doesn't it have potential 0? Equipotential, right? KQ by R minus KQ by R. KQ by R minus KQ by R. Every point is equidistant. The entire perpendicular bisector is 0 potential. The perpendicular bisector plane has 0 potential. That is also equipotential. Kind of looks like the plate. And now if you draw the field lines, the field lines will look like this. And you will notice these lines also will enter perpendicularly. And we can argue from here, if you look at the field lines, they look exactly the same. You cannot tell the difference whether these field lines are coming due to a plate or due to a minus q charge. Is that making sense? This is due to your minus q charge. So the field lines look exactly the same way as if there is a minus q charge on the other side of the plate. So that means whenever someone gives you an infinite plate, you can replace this plate with a minus q charge on the other side, and then you can just solve the problem. That's why this is called a mirror image method. The plate behaves like a mirror. Isn't that how an image forms? If you put an object in front of a mirror, you get an image on the other side equidistant. Is this making sense, everyone? So the field lines are identical. So we make an argument there. The field lines between the plus q and the plate look identical to field lines between plus q and minus q, right? With the distance of 2D, right? Plus q and minus q, where minus q is on other side at a distance d. Meaning your plus q cannot tell the difference whether the field is coming due to an infinite plate or whether it is coming due to a point charge. Is this making sense? So therefore, whenever you get this question, so this is the reason it is called a mirror image method. So if you have a plus q and if you have this distance d, the plate can be replaced with a minus q charge on the other side. Again, not a difficult concept. So this question looks like plus q and this looks like minus q and the distance is d, 2d. So what is the force between them? K q minus q by 2d whole square. Minus indicates attraction. But the energy part is interesting. If you look at the field lines, the energy of the system, K q minus q by 2d into half. Why half? Because only half of the field lines are present, isn't it? If you see, technically, even though it looks like minus q, remember there are no field lines at the bottom. So half of the space is not filled with field lines. We get half because half of the region has no field lines. Don't get confused with the force, because remember the definition of field, the number of lines per unit area, that does not change. The number of lines is energy. So since half of the lines are missing, you are getting less energy. We will talk about that in more detail in the next chapter. But yeah, field lines are actually a form of energy. half of the region has no field line. So this they won't tell you. Huh? They will just talk about the force ka part and they'll leave it there. So they can ask you as an energy. Is this clear? Now, if I give a modification of this, tell me how will you do this one? Let's say there are two infinite plates. Grounded, grounded. This is 0, 0 origin, 90 degrees. We have a plus q at d, comma. Find the force and the energy on this charge. We have an infinite conducting plate. I'm sure you studied the number of images in a mirror in school. Find the force and the energy of the system. So there I showed you for one plate and I can ask you for two. Let's see how you handle this. A little bit of optics, image formation in plane mirrors. That much I'm sure you can handle. Get me the force, Paran. Find the force on the plus q and the energy of the system. So how many charges will come? If you guys remember, and I don't know whether you learned it in school, if you have two mirrors at 90 degrees, you get three more images, isn't it? So this is what we do. So this plus q will create an image minus q. This plus q will create an image minus q. This minus q and this minus q will create one more image. So every time there is a reflection, the charge changes. It's a reflection of a reflection. So this minus q ka reflection on this plane is a plus q. So this thing will have three charges. So this whole system, so this is a reflection of minus q. You won't get my plus 2q. Basically, they partially create q by 2 and q by 2. That's the idea there. And then you're done. So this whole question has become like this. So there is a plus q, there is a minus q, there is a plus q, and there is a minus q. They are on a square. Of side 2D. I'm indirectly asking you to find the force. So let's say force is k q square by 2D whole square. I'll just call it F. Then this guy will attract with F. This guy will attract with F. And this guy will repel. The distance becomes 2D root 2. This becomes F by 2. So the net force will be F root 2 minus F by 2. That's your net force, where F ka value is this. And what about energy of the system? Remember, there are 6 possible pairs. So minus k q square by 2D into 4 times. There are 4 sides. Plus k q square by 2 root d into 2 times. There are 2 diagonals. The total 6 pairs. 4C2. But into 1 by 4 because there are field lines only in 1/4 of the region, isn't it? If I have to draw the field lines for this picture, the field lines would look something of this sort. the field length would look something weird like this. So there is only field lengths in 1/4 of the region. So is this clear, everyone? Now you can keep playing. I can put multiple surfaces. You can do all that mirror image thing. All clear with this? Now, if they really want to play more, they can do something like this also. I'll give this as a homework, give it a try and come. What if instead of a plane, you have a shell which is grounded? Conducting shell, radius r. And let's say you kept a charge q here in front of it at a distance d. So the question is, same thing. We need to replace this shell with a point charge. That's the whole point of the mirror image method. We need to replace the shell with a point charge. Let's call it small q. So what I'll ask you to do is this. So this is origin. This is d comma 0. So I want you to replace this 0 comma 0. Your charge is here plus q, which is d comma 0. So replace this shell with a charge. Let's call it q. And let the coordinates be a comma 0. So find the value of q and a. Means if I can replace this entire shell with a single point charge, which is at a distance a comma 0, so then I can replace the shell with a point charge and I can do all my problems. You getting this? Now, if I have to give you a little more context, I'll tell you what I'm exactly asking. Say, this is 0 comma 0. This was d comma 0, and this you have plus q. Here you have some, technically this will be a negative charge, that though it is understood. So what I'm asking, if I draw a sphere, and I'm telling you from here, if you take any random point on the sphere, if this is R1 and this is R2, kq by R2 plus kq by R1 must be 0, isn't it? Because the potential is 0, because it is grounded. That means look at this. So you have to find a point charge q with a such that the locus of all the points whose potential is 0 from these 2 points is a sphere. So meaning you choose any 2 points on the sphere. This distance and this distance, potential must be 0. This distance, potential must be 0. Is this making sense? So think about this. If you can figure it out, it's pretty straightforward. Unless it is literally hard to think. Yeah, that is how you can play with this thing, right? With a plain sheet or this thing. But technically, if at all they want to ask you this, they have to explain you the little story there before going ahead. Clear? So that is one thing you can try as a homework. It's a good one, right? And second thing, I'll ask you this also. Remember this thing which I gave you here, Q? Try this as a homework. Can you find the value of small minus Q? What is the value of the induced charge minus Q? Which is not this thing you're replacing with minus Q. The induced charge can be something else. Or let me ask like this thing. Find the surface charge density on the plate. Try this thing. This is a really good one. They can really play around like this. So think about how will you do that and how will you do this thing. So this entire mirror image thing, right, is technically out of portion, but yeah, when did advanced people stick to portion? They can, because they can always ask you, explain a bit, and you can go ahead. So then, with that, we are done with the chapter Gauss law. The next chapter is capacitors, which we'll do in the next class. And one more thing, this week, right? Thursday, I'm not available, right? Advance got over. I also need a small break. I got really exhausted with your seniors. I'm also traveling, so we will again meet up directly next Tuesday only. So this week there is no class on Thursday, but there is an exam till Friday, so make sure to give it. So next Tuesday when we catch up, we will start off with capacitors. Again, quite an important chapter. Capacitors and current electricity, the circuits and everything. 30 to 40% chapter will look identical. So it's really an important one. So please start doing Gauss law. The chapter, I won't say it is tough. It is very different than what we have done so far. You really don't have equations and all that stuff. You can see like there's a lot of arguments and proving things. So please make sure to do it. You have time this week, so finish your backlog, whatever you have. Again, I'm telling you, entire electrostatics, Gauss law, capacitor, gravity, all this electromagnetism is 33% weightage. You have wasted your time in your 11th, maybe आपका mechanics थोड़ा weak है. Don't worry about all that. Focus on अभी से जो भी chapters है, focus on them thoroughly. You have 60% portion in your hands. And once the portion gets over, I'll be taking 2 revisions, one mains ka revision, one advanced ka revision. So you will have ample of time to cover everything. But abhi se backlog mat rakho. If you start creating backlog from now, then there is no saving it. Whatever happened, happened. You still have some time. Let's figure it out. Okay, so any doubts, anything else, please stay back and ask. Or else I'll see you guys again next Tuesday. So yeah, so take care and stay safe. I'll see you guys soon.
Bye, sir. Thank you, sir. Have a safe
Yeah.
journey, sir.
Yeah. Any doubts? Yeah. सम्यक
सर
हाँ रे ये रिकॉर्डिंग कहाँ पे बंद करना है रे वेट वन सेक वेट